Welcome everyone, and welcome to GLA Summit. I'm Kamalakannan Rajan. I'm having a 10 plus years of experience in automotive domain and HVAC systems. So I've been using LabVIEW from 2009 version. I've also had a chance to work with LabVIEW 4.0, which has a base driver uh, working on which is evolved even before I born. I'm currently placed and working as lead in Value as a tools development team. So yeah, as you see from the older Eagle logo to the latest NI logo we have been familiar with. So today, yeah, I'll take up all the questionnaires at the end of my session. And today's discussion, or I'm going to present on how we handle data in a HIL system. Either it can be an device under test or for any validation or for any result analysis purpose. So the major item which I talk about is going to be DVR. Before I start, value at a glance, we are into electrification, lighting, interior experience, as well as ADAS acceleration. So the major area which I was focusing on here is ADAS and mainly the vehicle data signals. Yeah, so the topic which I want to discuss is about the data value reference. Yeah, basically, I'll try to elaborate and see and explain what data value reference and how it is being used in our use case. So, data value reference is basically a shared memory location where the location of data is passed on the wire, not the actual data. Yes, you can create a data value for a single copy of data or a set of data as well, meaning it can be of any data types. So it also helps in managing the memory and avoid frequent data copies which are created on any tunnels or any for loops or any while loops that we create. So it avoids creating a duplicate copy of our data, which would eventually slow our performance if we are dealing with any large set of data. Also, you would have seen sometimes when you have a large set of data like video recording or any audio data recording on the loop, so you will be ending up facing a out of memory issue error in the LabVIEW. So, and also this is how you navigate to data value reference under applications. Right click on the front block diagram and you go to application controls, and under memory control we have a data value reference panel for us. Yeah, so a quick difference between how the value is handled and how the reference is handled in LabVIEW. So the value is directly wired in LabVIEW, and if you see, you can see the data flow and also changes which has happens in the piece of code itself. And when the data is stored as a reference in the memory, so the data is stored in one memory location, and if you eventually want to change it, you can read from that location using this DVR and affect or change or modify the data which is there. Yeah, so these are the blocks, or how do you create a DVR. So there is a function for creating a DVR, and there is an in place element which is under the programming panel in block diagram, and you have delete value reference if you are working on the reference, and you can access this data. I hope my screen is visible and I'm audible. Okay, thank you. Yeah, so these are the building blocks for using a data value reference. And data value reference is basically mutex, and it also follows data flow. So what is mutex? So once data is accessed by an in place element, you cannot access it anywhere else in your code. That restricts your data flow, as well as it helps in having you facing the race condition, avoiding the race condition. So if at all you want to access your data from your data value reference, the major way is by using the in-place element memory structure, which will protect the data. No other code can access it until you are finished with it, until you close this and or write the operation. So it will be there in your code. So in the example which I shown in the screenshot, so where the input data is 100 and you can see clearly the data out is uh, wired from the reference, and you can see the data as 103, so it has completed all three operations. Yes, the one more option which is available in data value reference is, yes, as I said in the previous, it is mutex when it comes to writing or affecting the data which is in the memory. So if you want to read the data, like say if you want to explore a data in different areas, like for analysis, for viewing, for creating logs, you can have a multiple data read parallel read access option which is available, which is a unique option in DVR. You can have it without affecting the base memory of the DVR or the dataset which you created as a reference. So this is how you shouldn't be using it. So if you play within your in place element, as long as you modify the data element and explore it inside the in place element, you won't create any excess data from its reference, or you won't affect the memory directly. So when the moment you create the tunnel out of this in place element, there is a huge um, uh, I would say huge space where you create extra data on that, and it will affect your memory in terms when you handle a huge data. So the example which I'm showing is for only double, and as I previously mentioned, the DVR is not only for a particular data type, it can access even queues. So at that moment, I would want to touch upon how the memory management for a large data set can be handled using this DVR. So as I previously said, you can use the data value reference to store data without creating extra copies. And data value reference, when compared to queues, it is more efficient as you only pass the reference of the data, not the actual data in the queue itself. So instead of transferring data to a queue, you can create a reference to a data and pass around the reference. Meaning, you can see in the below example. So I've created a U8 array and I've created data reference, and that data reference is passed into a queue. So only that the reference being handled, the queue is remains the same. So the data still is referred in the queue as even data value reference. So as I said, to operate on data, you need to use in-place element structure. So to operate any data, these are the options available in the in-place elements. As you see in the right corner, you can place an array index or split array, or even you can do any arithmetic operations or any algorithm operations which can be done in place element, and you can update your original data. So as I said, the data read reference or write element border node accepts a data value reference as an input, allows you to operate on the data within the element structure itself, and it replaces the data in the original memory space. Yeah. So the quiet example I can show you for how we handle the data when it comes to large data sets. When I say large data sets, using a sensor data, let's say you have a vehicle CAN data, or you have a vehicle automotive Ethernet data which is coming from the vehicle, or any radar sensor data or Validine sensor data. There will be huge sensors. If you call it off, like say if you place two in front of a vehicle or two in rear side of the vehicle, any sensor, let's say ULS or radar or Validine. So each will be recorded as a different data sets, and you will be having a huge file size for the recorded duration. So when those datas are already in place, either in local or any cloud storage or any RDMA devices, so I would say these are the options which we are explored using DVR. We access this large data and from the cloud storage, and we process it in a read binary format, as well as we do analysis within our in place element, and we do provide the analysis results. Let's say it can be a data validation of the recorded data. So when it comes to affecting the data, so the same local data or cloud data storage from the read from the data, and if at all any data modifications or if any data fix is needed, let's say if an alive counter from a can signal is missed, and that is only for the allowable limit. Let's say you set the limit from your validation tool, and you can either send it back to the original data storage, um, uh, without duplicating its memory. You can handle that data fixing operation inside your in place element, and you can fix this data. So these are the two options which are explored, like for a data set handling, and data correction can be done. And as I said, this is one of the example which we have. Like we have a feeder queue which is continuously reading from data file source, and we'll be creating it as a data set of using the DVR, as well as we place it in the queue. So once the DVR is created, we'll be carrying it for a different type of analysis. Let's say compression parameter analysis. Let's say if you have a data which is compressed or not, you want to analyze it, that can be done. And any data marker is there. Let's say a alarm counter can be marked in a can dbc or can fd file, that can be easily identified and analysis for the data integrity. So this is how we perform analysis on over any hill system. Like as I said, there are other options for data value counters and algorithm implementation as well. So the other option which we okay, so this is a quite one example where we handle this data and get the data frame from CAN data, and we do this alive counter fixing or analysis. If let's see, we do have a data set where we know exactly the alive counter should be present in any data, so that has been handled here as a data analysis counter. And one quiet example is the data mark analysis. As I said, there are some, let's say if you take an image perspective, it will have an embedded data, and the actual data will be starting with any markers, with the example of any lossless compression or any data compression or any JPEG image will have a prefix of data, and end of the data will be provided in the image itself. So those validations can be done within the region of in place element without copying the data from the large data sets. When I say large data sets, it's over 8 GB or 16 GB of data handling in parallel to different streams, CAN or video, all set of data. So one use case that will come up, that we are working on right away, is reading the data from the large data set and applying it for an algorithm and processing it for the visualization. So we have used data sets from image sensor, so where we apply license plate detections and face detection, even object tracking algorithms or blur algorithms are implemented, and it is used for the visualization. So for all of these purpose, the duplication of data in the real time case, let's say 30 fps or 10 hertz signal or 100 hertz signal are processed in DVR, and visualized in our visualization tool. So we use predominantly the data sets with the help of DVR without affecting the memory space, available memory space. So this is one of the great tool which I come across when we implemented this memory dataset handling, is this desktop execution trace toolkit. So where you can uniquely trace what VI or which VI is taking the memory and how many threads being handled, or in which CPU it is handled, and even you can do a core allocation based on your priority on the algorithm which you process or which you analysis which you do on any data. So yeah, so this is how the VA times or sub VA times or total times can be calculated. and you can avoid huge memory build up when you face any error or any pop out which is out of memory issue. So this uh, desktop trace execution tool will help us in handy. Yeah. So to conclude my slide on DVR, so DVR is a potential use case when we use large set of data. It is mutex, as I said. Multiple in-place structures can exist in the same VI, but only one can operate on the data from a reference. So if any process or if you place any while loop inside this in-place element, at the parallel you cannot access until this in-place element is closed this operation and released its point. So that is the only I would say advantage. Some places it is a disadvantage. So this is how it operates. I'll also like to touch upon our NI case study on our hills. So I'll share you the link across. So this is the case study which is done for our hill architectures where huge set of developers were involved, and we have client-based hill systems as well as in-house hill system being deployed across the globe. Like I would say 50 hills were deployed all across the globe. And another test case where our DUT test cases and system test cases case study is highly appreciated by NI in terms of tool chain which we maintain. Yeah, that's it from my side. Yeah, I'll take some questions. Yeah, NI Trace desktop trace toolkit is not free. It's paid. It's paid. Before the use case, let me go to my presentation. Yeah, that's an example where I created. Yeah, so the okay, so the use case which I have provided you, it's just a screenshot which I'm placing. I will share my screen again. Sorry for that. Yeah, so I think this is what you're talking about. So this is okay. So if I enlarge this, okay, I think you can see the data. So a data value reference is coming into the place, and we are handling this UI data, and the data analysis, marker analysis has been created here. So this is just a screenshot which I placed to mention the operations need to be done within the DVR. So it is for the explanation perspective. Yeah, sorry about that. Yeah, I know there is no reference, but you can see clearly the reference is inside this. I will enlarge this for you. Maybe this is a test VI, and yeah, you can see this data value reference. And from the reference, we are utilizing the replace array element, and we are again writing it. So this is a sub VI where I just opened it and get a screenshot and placed inside it for you for the explanation. The same is here. So you can see the data reference is there. It's a part of our sub VI. Yeah, thanks, Janath. I hope my presentation is useful. Feel free to post any questions in any areas or LinkedIn or any GLA forum. I'll try to answer the questions regarding the DBR. Um, Thanks everyone for joining. Thanks GLA Summit for giving me this opportunity to provide uh, my presentation. Thank you so much all.